everybody who is watching this video. My name is Olenjolai Single. Once again, you have invited me to be in your school, to be in your mobile phone, to be in your computer, to be in your smart TV. I thank you for that opportunity that you've given me. Okay, you invited me in your classrooms, you invited me in your dormitory, wherever that you are when you are watching this video. Okay, I would like to welcome you. I'm from United Republic of Tanzania, beautiful country. I would like to welcome you into our Tanzania Online Advanced Secondary Schools in square bracket OLENJOLAIM, where you will be enjoying the contents that we are preparing, which are well prepared and even simplified in a different style, so that you can take them to yourself. And then it is, we call that, the courses we are designing is just you can take on your own pace. Okay. So in these online schools, we have a vision, and this is our vision. So we like to prepare students who are Tanzanian Africans and elsewhere in the world who can take the classroom instructions in science, mathematics, combined with the spiritual knowledge, the knowledge that they know about God, and hence to solve real life problems. So that's why that we have, this is the one of the of our YouTube channel that we are training A-level students, advanced physics, advanced chemistry, and advanced mathematics. Not only that, but also we are teaching them basic applied mathematics for the Form 5 and Form 6, or class 13s to class 14s in some of the countries. But again, we have some other two channels that we are training, or we are teaching students the spiritual knowledge, especially the knowledge of the Word of God. That's called the Ufalme Mbinguni Umekaribia Tanzania. We are teaching the Word of God in Swahili language, because that's our national language. And then we have another channel, which is a global channel. Okay, it's a local, but we have a mindset of the global channels that called the Kingdoms of Heaven Come in Tanzania. We are teaching everything about the Word of God in English, so you can take advantage of those stuff. So regardless that we are teaching you and taking care in science and mathematics, but also we have a great business and responsibility. So one of our assignment to take care about your spiritual health, because we realize and we learn that from the facts that if you combine the two knowledges, then you'll be a dangerous person in this world. So this is one of my assignment that I'm doing. So I'm trying to think about you as I'm solving a problem. This is one of the problems that I have to solve before I leave this planet Earth. How about you? Which problems you are expecting to solve? Or you want to add some problems in the world where we are living, but we're expecting a certain solution of a certain problem. Well, so we have one of our YouTube channels that called Tanzania Online A-Level Study Schools. This is the corresponding. This is just like implementations of this online school. We have also some other 5 YouTube channels that if you watch the beginnings, it means that you watch the intro of this video, you will notice that we have included the 5 links for other YouTube channels. So make sure that you click them, and then you will get hosted and even connected with some other channels that we didn't mention at this time. Make sure you subscribe for you, because in this channel we are going to upload more than 500 videos, right? Because advanced physics, advanced chemistry, advanced mathematics, basic applied mathematics are very intensive subjects. So they have a lot of topics and long topics. That's why we call them. For example, today we are in departments of advanced chemistry, and the subject is advanced chemistry, and the main topic is advanced organic chemistry, right? Advanced organic chemistry. So this is the main topic. For example, advanced organic chemistry itself, it contains 9 topics that the students has to cover. For the Form 5, has to cover 7 topics among the 9 topics. And during the Form 6, he or she has to cover 2 topics. If you're parents, and then you are thinking about how your students can learn science, advanced physics, and advanced chemistry, basic applied mathematics, and advanced chemistry, then this is the right place for you, right? So make sure that you let them. So this the syllabus we are using these programs, so in this online school, is the syllabus of United Republic of Tanzania. However, that this material might be used elsewhere in the world, right? So let us go to business. So today we are in lecture session 6. We want to teach about rules of showing organic chemical reactions. There are some rules that we have to follow. Whether we are learning about alkane, we have to follow these rules. We are learning about alkynes, we have to follow these rules. We are learning about alcohols, we are learning about aromatic hydrocarbons, we are learning about aldehyde, learning about ketones, carboxylic acid, derivatives of carboxylic acid. So regardless of which topic we are going to learn, except the polymer, we won't use these rules or these rules in so much details. But for the rest of the topics, we need these rules. That's why we are teaching you at the beginnings of this program. So let me do the quick review. Okay, let me link my quick review my lectures, so the present and the previous video. So quick reviews. So in terms of quick reviews of what your session 05, we taught you basically, first of all, we taught you about positional structural isomerism, right? Or isomers. And hence we say that this is positional structural isomerism. We say that these are the compounds which have the same molecular formula but different positions of what of the functional group or substituent group. So they can be formed by changing the positions of what is substituent group, and also, or we can by changing the positions of what is functional group parties. And then we taught you about stereoisomerism. It's just like a correction of the homework, but I realized that many students, they fail to go through it effectively. Stereoisomerism. And then I told you that we have two types of stereoisomerism. We have geometrical stereoisomerism and we have optical. But according to the syllabus, we have to teach you only geometrical isomerism, when that we learned about cis and trans isomers. Okay? Again, we talked about something called the types of bond cleavage or bond. We call it the types of we call that subtopics bond breaking mechanism for organic reactions. So bond breaking. So bond breaking, and to say that we have two types of bond breakings, okay, because you are forming and you are breaking bonds in organic chemistry and also forming bonds. So you have two. We have homolytic bond cleavage, and also we have heterolytic bond cleavage. So homolytic, this is the types of bond when the bond break, or is a cleavage of the bonds between the molecules or between the atoms. And when the bond break, okay, you got it. And when the bond break, so each atom leaves its electrons that it has contributed during the formation of covalent bond. And then heterolytic, we say that in this state, you find that you have a bond, for example, that we have CH3 and chloro. Okay, chlorine. So there's a bond between carbon and hydrogens and carbons and chlorine. So because chlorine is more electronegative, when the bond break between carbons and chlorine, you find that chlorine is withdrawing all the electrons, all the bonding or all the pair. It means that all the pair of electrons, the pair of covalent bonds, the pair of covalent electrons that has been used to formulate the bonds between chlorine and the carbon. Because remember, chlorine is the non-metal and also carbon is the non-metal. So when they form a bond, we call it covalent bond by sharings of the electrons. So with this homolytic, heterolytic, we say when the bond between carbon and chlorine break down, then the more electronegative atoms withdraw both electrons which have been used in forming of a tertiary bond. So for example, if this bond break, chlorines will withdraw 20 electrons. One belongs to it before even the formation of this covalent bond, and the other ones, belongs to carbon. That's what we call heterolytic bond breaking. In case that you want too much details concerning about this, my dear student, session 05 is still in our YouTube channel, Tanzania Online A-Level Circuit School, OLENJOLAIM, and we have created a playlist of what advanced organic chemistry, right? And hence we have also some other playlists according to the topics. This is general introductions of what organic chemistry. So when you go there, rather because you'll find many videos, so you have also to follow the guidance that I'm giving you in order to take you where you want to go, right? So let us come to this now. Rules of showing organic chemical reaction. We are not teaching you yet about, we'll teach you in the next sessions about types of organic reaction. But here we want to teach you about rules that we have to follow. Because in organic reactions, we learn all the many chemical reactions by following mechanisms. Since we call it mechanism. To mean we follow some steps in breaking bonds of reactants to form new bonds of product. So there are some rules that you have to follow, right? And this is the easiest way that we are teaching students and even myself that we have mastered organic chemistry. By breaking bonds and by doing something we call it mechanism, right? Mechanism means that we are breaking bonds and we show how do we break bonds and how do we form bonds. That's all, right? So you say that rules of organic rules of showing mechanisms, or you can say that mechanism of organic chemical reactions, right? Showings, okay, so you say that rules of showing, so let me correct it, do this minor correction to make a sense for you, or just say I can have this simple. Rules of showing, I think that's better if I do correction, might help you. Rules of showing what? Rule of showing mechanism. What the means of mechanism? Step to step. Rules of showing mechanism. Rules of showing mechanism, right? Mechanism of organic. Rules of showing mechanism of organic reaction. Okay, organic chemical reaction. Okay? In case also you feel from your heart that you want to offer your thanksgiving, you can offer it through this telephone number 0759 7453 31. Okay? Organic chemical reactions. So, before even I mention the first rules, I want just to give you the overview. These rules, these are the rules. Okay, these are the rules that have to be followed. Okay, followed in breaking. Okay, in breaking bonds. Okay, of what? Of reactants. Breaking bonds of reactants and the forming new bonds. New bonds, forming new bonds of what? Of the product. Of the product. So these are the rules that have to be followed, or might be followed in breaking bonds of reactants and forming new bonds of what? Of products. Okay? So by following these rules, a student or a chemistry student or a student, okay, may understand many chemical reaction. We understand the mechanism of many chemical reactions. How do we understand mechanism, we understand mechanism of many chemical reactions. Many chemical reactions. Without doubt. Without doubt. Okay. So you say again that the arrow or half arrow, full arrow and half arrow, indicate what the arrow itself, not half arrow. Half arrow, that's indicated about in case of breaking the bond. The arrow indicate a movement. A movement of what? The movement or flow. The movement or flow of electrons. electrons from electron donor, or we call it nucleophilic or nucleophile, from electron donor or nucleophile to the electron acceptor. Electron acceptor. So electron acceptor, or we call it electrophiles. That's very important keyword. The arrow indicates the movement or flow of electrons from electron donor, which you call it in organic chemistry called nucleophile, nucleus loving, okay, to the electron acceptor, or you call it the electrophile. So, after giving you brief introduction, remember that this is the introduction, okay, this is the brief introduction. After giving you these introductions, we say that, okay, so we say that the following are the sum. The following are the sum examples. The following are the sum examples of rules that are used to show the mechanism of organic reaction. So the following are some examples of rules that are used to show the mechanism of organic reaction. To show the mechanisms of organic reactions. Okay? Mechanism of organic reactions. So that is what we want to say. Okay? So the first rule, we say that the flow of electron the half arrow shows that the type of body breaking is homolytic. Okay? So show that it is homolytic. And that's half arrow. This is the way we are going to show it. Either this one, or you can show in this way. That's the half arrow, that's the symbol. Right? Homolytic body cleavage. Body breaking. Also it shows that one electron, it shows that only single electrons, okay, only a single electron, only single electrons single electron is transferred from nucleophile to electrophile. Then we say that again, the curly, or we call it a full arrow, curly or full arrow. Okay, the curly or full arrow shows that the type of bond breaking is heterolytic bond cleavage. Okay, so its symbol is this one or this one. Okay, and it shows that two electrons are transferred, right? Electrons are transferred from what? From nucleophile to electrophile at the first rule. This is the first rule that we have understand. And the first rules talks about half reaction. No, talks about types of bond breaking, whether it is homolytic or heterolytic, and also tell us about half arrow and full arrow, but also tell us the number of electrons which should be transferred, right? So, in order to So before I give you some examples that we have to learn this one, so we say that whether we'll be using this one, however that we'll be using this one rarely, or use this one which is full arrow, or we are going to use this arrow like that ones. So we say that okay, they have what? They have starting and the end of 40 of arrow. So what do they mean? The beginning or starting of the beginning of the arrow. The beginnings of arrow represents what? Represents electron donor, which is what? Nucleophile, right? And the end of 40 of arrow, whether half arrow or what, presents what, okay, indicates what. So this one indicates the electron what, electron acceptor. So this is just for the purpose of understanding. Electron acceptor, which means that what, electrophile. This is the electron donor, like that. So we say that in that this, if this is the nucleophile always, and this is the electrophile. So, for example, if you are transferring two electrons, this is what is going to happen. But remember that this number of transfer, so not this one. The number of electrons transferred the number of electrons transferred is only considered when the previous or the bond or the old bond, we say that when the previous bond before breaking, previous bond is covalent. If it is electrovalent, then that's not taken into consideration. We just use the full arrow for the transfer of one electron. What does it mean? Listen carefully. For example, if you are breaking a bond between carbon and the hydrogens, or let's say carbon and chlorine, this is easier for you to understand. This is non-metal, this is non-metal. So the bonds there which has been formed, it is what? Covalent sigma bond, right? So if you break, if chlorine is more electronegative, if it restores all the electrons, then we say that if it is heterolytic, you put the cleavage. So chlorine is going, because this covalent bond has been formed by sharing two electrons. One electron is from chlorine atom and the other electron is from carbon atom. Then they form covalent bond. If you want to break now, so this is, let's say that the two electrons are shared. Two electrons are shared. So if chlorine is more electronegative compared to carbons, when the bond break, chlorine withdraw both paired electrons. So it means that carbon here, we use this notation partially positive and chlorine is partially negative. But this partially negative, chlorine is the one that possesses both electrons. So if you want maybe to form another bonds, maybe with benzene, something like that, benzene like this way. So you say that we use this arrow. The full arrow, it means we are transferring two electrons, not one electrons. Transferring two electrons, right? That is in case of covalent, and the bond breaking is heterolytic. I want to clarify this point because it can make confusion. I know where the confusions will rise, especially for those students who used to learn through with thinking. Means that they think when they are learning. But for those who are always receiving information, they won't get any battle. They just know, they claim, and off they go. So for homolytic, for instance, and this also homolytic works for covalent bond, for homolytic. So for homolytic, what we said? We said that we have a bond between chlorine and forming chlorine molecule. This is also covalent bond. The chlorine molecules mean that we used to write this way. It's a covalent bond. But that covalent bond has been formed by what? One chlorine atom contributed one electrons, and other chlorine atoms contributed, you don't listen. One chlorine atom contributed one electron from formations of this covalent bond. And also one chlorine also contributed one electron to that chlorine, to the formation of that covalent bond. So because the electronegativity between the two atoms is the same, when the bond break now, it will be homolytic. So this one will withdraw its electrons, and this one, the chlorine atoms also withdraw its electrons. And that's why that we say there, in this bond breakings, we don't form whether partially negative nor we form neither partially negative nor partially positive. We don't have nucleophile. We neither have nucleophile nor electrophile. So here we say that the product now, we are going to have two free radicals. That's what I taught in session 5. Right? So this is transfer 1 electrons. And this is transfer 1 electrons. But this is only for covalent compound. But what the challenge now? The challenge is sometimes you can find, for example, for the next example, we want to show the bond breaking, for example, let's say, of sodium react with hydroxide. This is the electrovalent bond, right? This is metal, this is the combinations of non-metal. So when you say that here we have a bond between this one, right? So this is the electrovalent bond. So what happens to the electrovalent bond? We have a metal and non-metal. How does it form? Means that one atom is going to transfer its electrons into another atom. So for example, your sodium, when it ionizes, if you give it a phase ionization energy, it becomes sodium ion. So it's lacking 1 electrons in its valence shell. Okay? So what OH hydroxide, it contains it contains more than 1 electrons, which is negative. We used to have negative sign. So for instance, that these compounds, they formed this compound when you have sodium ions and what hydroxide ions. We used to learn this one in Form 2. Should you remember that? So then, what happens? So this is rich in electrons, so this is nucleophile, this is electrophile. They come together, they combine, they form sodium hydroxide. So when we want to break this bond, this is more electronegative compared to this one. So what's going to happen? So this one is going to store, it's 1 electron, right? It's 1 electron which has transferred the beginnings to sodium. So when now we have these hydroxide ions, it only contains 1 electron, but once we form the bonds, we just use the full arrow. So the question is, for those who use to zinc, hydroxide contains only 1 hydrogen. Why are we using full arrow to show that it's going to react to another compound? The reason is I told that the number of electrons transferred with respect to the arrows, whether it's half arrow or full arrow, is showed by what? Is showed by what? Is only limited for covalent bond. When it comes to electrovalent, that doesn't work, right? Because electrovalent, we know that this is more electronegative, and it's the one that will store all the bonding electrons. Okay, I believe you have understood. So let me give you examples of how do you use that rule. So if you join me right now, you're warmly welcome. My name is Olenjolai from Tanzania. I'm teaching today a concept that called the rules of showing mechanism of organic chemical reactions. So you're only welcome, you're in the right place. So stay connected. So you have an example here. Okay, so let's say example 3. Complete the following reaction. Complete the following reactions. Complete the following reactions, chemical reaction. Complete the following chemical reactions. With what? With following reaction with mechanism. Okay, following reaction by showing, let's say by showing the mechanism. What does it mean? It means that the mechanism, you have to show the mechanism. How is that product formed? We have ethyl ether, and then a bromine atom there. Then we react with sodium hydroxide, like that. So, but this one is aqueous, in aqua state. Roman 2, we have methyl, we have carbons containing chlorine, and we have CH3. So remember that I will solve only for, I will look the mechanism for one reaction, and the one reactions I leave it at the homework for you, for a student. So you have a choice. Which one would you like me to do for you? Once we do the rest. Again, we have example 4. I think yes, I'll do both of them. Yes, I have example 4 here. So this will be your homework. So this will be homework what? 06. Complete this reaction with what? With mechanism. Mechanism. CH3, CH2, and carbon, CH3, CH3, chlorine, plus potassium cyanide. Students, they used to spend their time on doing something which is unrelated to what they are doing. I appreciate that students are students. Students are always what? Students. They are very busy looking their fingernails. So complete the following chemical reactions by showing what mechanism, right? So you have these reactions. This is bromomethane, reaction with sodium hydroxide, but in the aqueous state. And also here we have okay, what are the names of that compounds? So it depends. You can name it as one chloro hyphen no 2 chloro. Okay, 1 methyl hyphen 2 chloro propane. Okay, we write this structure and reaction is potassium hydroxide. Then for you, I would like just to ask you to do for this. This should be a homework, and very simple homework. So solution. Okay. So you say that we have these compounds. Well, so listen, that's the way we are going to solve. So first of all, write the open structure. Okay, write the open structure. So you will see what is going on. We have hydrogen here, we have a hydrogen here, we have hydrogen here, we have hydrogen here. Right? And then, because the reactions, we have a bond between sodium and hydroxide atom. Right? So we have to break the bond, and also we have to form the new bond. So that's the business that we are going to do. So to break the bonds, listen carefully. When you start with these organic compounds, we have how many types of sigma bond? We have 3 types of sigma bond. The first one, sigma bonds between carbon and hydrogen. Second one is the sigma bonds between carbons and carbon. And the third one is the sigma bond between carbon and bromine. Right? Chemistry is beautiful. And then so if we go to another reactants, which is sodium hydroxide, we have 2 bonds. We have one, this is one electrovalent bond, but also you have covalent bond between oxygen and hydrogen. Right? But we treat it as one compound. So, between carbons, so where are we going to expect, where do we expect it to find the bond breaking easily? Because we find that these carbons and this carbon have the same electronegativity. The electronegativity difference between hydrogens and carbons is very small compared to electronegativity difference between carbons and bromine. So bromine is more electronegative atom compared to all the other 2 atoms, carbons and hydrogens. So it means that under specific conditions, we say these bonds will break, and bromine is going to restore all the bonding electrons, because this is covalent bond. Bromine contributed 1 electrons, carbons contributed 1 electrons. So the bonds, the types of bond, because the bond breakings, these are they don't have the same electronegativity value. So this is more electronegative compared to this one. So it will restore both bonding electrons, which are formed with covalent bond. Similarly, when we come to this side, this is the electrovalent bond. So when the bond break, always this one is going to restore its electrons. Right? So the next state now, we say that we have what? We have CH3, and here we have CH, we have H, okay? And this one becoming partially positive, and then here we have what? Bromine, but this bromine will become partially negative. You see now the importance of general chemistry. Talked about partially positive and partially negative in chemical bonding. Then this one is going to be sodium, but positive ion, and then this becomes hydroxide, but negative ion. Okay, we broke the bonds between bromine and carbons, and broke the bonds between sodium and hydroxide. We cannot break the bonds and form the same type of bond. When we break the bonds, then we have to form the new bond. with different atoms. So for that case, we broke the bonds between carbons and bromine. We cannot reform it, but we form a new bond. This is partially positive, acting like a metal. This is negative, act like a non-metal. So listen now. So listen, where we have to show the rules. Okay? So we show the rules in this way. So between this and this, which is nucleophile, this is electrophile, and this is the nucleophile atom, right? So if a nucleophile, always an arrow starting from the nucleophile towards electrophile, towards the partiality positive there, right? Again, that's the point of interest. We're very interested in forming the organic compounds. We have against inorganic compounds between bromine and chlorine. This is acting like nucleophile, this is electrophile. However, that's not organic compound. But we have to show that the arrow is just like this. Right? So afterward, what do you say? So we say that here we have our end product is CH3, then we have carbon hydrogens, and this one is hydroxide. Is now we change towards what? Alkyl halides, but now this is going to change, become alcohol. This is the one of the preparation method of alcohol. And here we are going to have sodium bromide. So that's the end product. So it means that we say that CH3, CH2 bromine plus what is sodium hydroxide, the end product is what? The end product is CH3 is CH2 OH plus what? Plus sodium bromide. Okay, so that's all. Then you come for Roman 2. Roman 2, we have this compound. So similar, we have to write open structure. So we have CH3, and then you have carbons, you have chlorine, but again you have CH3 double. So this means that CH3 and CH3. At least today we are beginning to teach you advanced organic chemistry. Because really we are going to show you what are we going to do throughout the whole business. So this double structure plus what? We have again what? We have potassium hydroxide. So potassium and hydroxide like this. So listen carefully. So these are the two methods, that's why we have combined them. So you see the trick when you are writing molecular formula, this is the open structure, right? So when writing the molecular formula, this is the way that we write. Okay, well, so if that's the case, we come. Again, we think, how many types of covalent bond do we have in this organic compound? Right? Okay, we have how many? 3. The covalent bond between carbon and hydrogens, covalent bonds between carbon and covalent bond between carbon and chlorine. How many types of electrovalence bond do we have in potassium hydroxide? Only one. The electrovalent bond between carbon and potassium and hydroxide ions. So what happens? Where do we expect to find a bond breaking? Well, so we expect to find bond breaking between carbons and chlorine because we have more electronegative, means that there is high electronegativity difference. Chlorine is more electronegative more than even other atoms. So then this, the bond breaking here undergo is heterolytic. Chlorine is going to store both electrons have been used to forming the covalent bond between carbon and chlorine, right? And then here also the bond cleavage will be taking this direction. So this, okay, so afterwards we have CH3, and then we have carbon, and then we have CH3, and then we have what is CH3, and this is partially positive, plus what is chlorine, but partially negative, and then plus potassium, and then plus hydroxide. Okay, so we have our reactants now, CH3, and then you can say we can have the CH3, and CH3 2, you can write this molecular formula. But this one again still have partially positive, plus chlorine, which is partially negative, plus potassium, which is positive, plus hydroxide, which is negative. So listen, so you have broke the bond between carbon and chlorine. We cannot form the new bond between them. So you have to form the new bonds between this organic compounds is another nucleophile. So this is the nucleophile. And this now it's electrophile because it is lacking, it's electron deficient. This now act like a nucleophile but it's not for organic compounds. So what happens? So this is what we call a full arrow, right? So it will be transferred there. And then this one also transfers electrons to potassium. So what are you going to form? So CH3 and then carbons, CH3 but 2, and then here we have hydroxide. So it is, so now we have alcohol, and hence we have potassium chloride. So that the end product. So we say that CH3, CH chlorine, and then CH3, but 2 molecules plus what? Plus potassium hydroxide. This will make what? This will make CH3. Then this is carbon hydroxide. This is CH3, 2 plus what? Plus potassium chloride. That's the end product. At the end of the mechanism. Is it simple? You can say it is simple, but remember that this always is the first rule. Huh? Don't make jokes. Where have you been? So make sure that you do example 4, which is the homework, and then to submit in the comment section of this video here. You have to click the comment section and you write the reaction like this one, whether by using Word. You have to know. I think that the Word is the best one. So you write, or even there, you can write on the Word or you can write on the exercise book, and then you can see how you can attach it in the comment section. Okay, that's the first rule. So you have to go for the second rule, right? Nothing there. And so on. And so on is JJ. So this rule is concerned with those compounds act as nucleophile. Act as nucleophile by using localized pi bond. Situated between identical atoms. Situated between identical atoms. So between identical atoms. These compounds undergo electrophilic. These compounds undergo electrophilic addition reaction. Addition reaction. Addition reaction on showing reaction mechanism. Addition reaction. I'm showing reaction mechanism. Showing reaction mechanism. The arrow should be start. Should start from the center of pi bond. Center of pi bond and pass through that atom to which they're coming, pass through atom to which the coming electrophile electrophile attacks or attach So he said that in the other carbon atom that is deprived by pi bond, the electron should become positively charged. Okay. So this is very important. The other, say that the other carbon atom, the other what? Carbon atom that is deprived, okay, that is deprived by pi bond. Okay, by pi bond electron. Then should become positively charged. Become positively charged. Yeah, should become positively charged. So let me explain before I give you an example. Listen carefully. This rule, which rule? This second rule is concerned with the compounds acting as nucleophile by using localized pi bond. Then, how many types of nucleophile do you have? I forgot. 3. The first one, negatively charged ions. Second one, yeah? Pardon? They don't remember. The second example, the second type, we said that the compounds which act as a nucleophile by using the localized pi bond. And then the third one, we say that it's a group of organic compounds, or it's a group of compounds which act as a nucleophile by using lone pair. This my students have forgotten. Okay, anyway. I don't know about you online, who is watching online. You have forgotten session. That's what was it? It was session 2. You're in session 6 now. You have forgotten everything. So in organic chemistry, I want to tell you, we are going to have more than 30 sessions. I don't know how many are there, but I not even 30. You can reach even 50 sessions. So you have to get prepared and remember the stuff that you are learning. because that's why we call that the fundamental. The first topic is that build the foundations of organic chemistry. So okay, I was explaining about localized pi bonds, and then my physical students here has disappointed me because they forgot what is in session 4. So I'm trying to think when I'll take them to session 44, what they will still remember. Okay, so situated between what identical atoms. So this is localized pi bond. So it's not the localized pi bond between identical atoms. So localized pi bonds may be, for example, between carbon and carbon, between oxygen and oxygen, that's the meaning. Between nitrogen and nitrogen, if it does exist, that is. These compounds undergo electrophilic addition reaction. I will teach about tests of organic reaction. On showing reaction mechanism, the arrow should start from the center of pi bond and passes through, and this arrow passes through the atom. This is the rule, and pass through what? The atom to which the incoming electrophile, right? Attached, is attached. Okay? Attached electrophile is attached. So let me make this correction. Is attached. So it has to pass through the carbons, okay, where the incoming electrophile is attached. The other carbon atom, the second one, which has formed the double bond or the triple bond, okay, or the pi bond. Carbon atoms is deprived by the pi bond electrons should become what? Positively charged. What does it mean? Before I give you an example, listen. This rule stated, first of all, this is organic compounds which react by using localized pi bond. There we have one sigma bonds and one pi bond. I left the homework about, in case of alkene, for triple bonds. How many pi bonds are there and how many sigma bonds and why? No any students have submitted that homework in the comment section. Why? Oh, you know, we are Tanzania. We don't know how to use comment section. Okay. May God bless you. Okay. So what does it say? So here we have pi bond and sigma bond. Pi bond is weaker than sigma bond. So what happens? So if you want now to say that this one is going to react, you want to break one bond and then break something else there. It means that the reaction, for example, that suppose we have a certain nucleophile somewhere else. It's the nucleophile. So it means that the arrow always starts from the center of the pi bond and then pass through the carbons where the incoming electrophile will be attached, right? Incoming electrophile is attached, or will be attached, will be attached. So when these bonds now, so listen, so this is the other carbon atom. This is the carbon that is going to receive the incoming electrophile. Once we break that bonds, we say that these carbons will become partially positive, and we still have the sigma bond between these two carbons, and the other ones will become partially negative, and then see a 40 electrophile. So this electrophile, that's why it will come and attach there. So these carbons, the other carbons become partially positive, and this one, so here now, we have our electrophile. That's all. So this part against, we can have another atom that will attach there to make sure that the bonds are well stated or well defined, right? So let us go to example. I don't need lazy students. I need serious students. So if I ask you a question about any session, you have to answer that question because it's your responsibility to remember everything that I'm teaching you. It's your responsibility, and you chose yourself that responsibility. Nobody who forced you to study the combination you are studying. Even if you've been forced by the parent, but all in all, you're the one who wrote it. Who wrote that combination? I want to study advanced chemistry. Okay, you're welcome to study advanced chemistry. And in advanced chemistry, you have advanced organic chemistry. And this is what we are trying to help you. We are helping you, we are not killing you. Can you imagine if you go through this information yourself? You do the Suliatima, we call it. What happens? I think that you could have given up along the way. So let me give you an example. So this will be what? Example 5. Complete. Complete. Let me see how many reactions are there. H1. We have 2. Complete. The following reaction by showing, or with mechanism, by showing what mechanism, or sometimes that you say that with what, with mechanism. Even if that you won't be asked to show mechanism, but to show mechanism is the easiest way to remember reaction. For example, for me, I don't need to claim all the reactions of alkene, right? Just want to know how can I show, by using the mechanism, how can I deduce the end product, that's all. I claim inverse reaction for example, can you imagine that if you claim the reaction for ethene, reaction for propene, reaction for until maybe, for example, nonene, right? Maybe, for example, octo, deca, the kene. That is only for one hydrocarbon. Some other students, they say, sir, you are not blessed to claim. Yes, I agree that. I fail completely to claim. How about you? Are you good in that? I know some will say yes and some will say no. Because you know some of students, they've reached the level where they are through claiming. But some of them, they have been claiming because they don't understand what they are studying about. So now when it comes that you want to solve real life problem, then you need to understand. The real life problems does not demand you what you have claimed. The real life problems demand the knowledge you're extracting from the educations you have got in the classroom. So that's why every time I will be challenging you, and I'll be letting you know the disadvantages of cramming. Yes, if you cram, you'll pass exams, because most of the exam in Tanzania, they measure the level of remembrance, or level of, yes, remembrance, that's all. But now if you come to life, you'll suffer, my dear student. I want to tell you. How are you going to suffer? There's nobody who will ask you that, I have this problem, so you are going to state what is organic chemistry. Organic chemistry is a branch of chemistry that deals with organic study of organic compounds except carbide. No, nobody who is interested to hear that definition except a student who is studying organic chemistry. What the community want, this is the problem we have. Apply what you know that it will fit, and then solve the problems. What you want the output. That's all. So then from there you say, hey, if I could know. That's what we are telling you in advance. In Swahili you say that, ningejua. We are telling you in advance. You should not wait that time. Ningejua. You have to know now. I know that you are king of cramming. You are a queen of cramming. I know that. But there is limitations, because I have some of my colleagues who are expert in cramming during our undergraduate education, means bachelor education. But when we graduated, the truth has been revealed, because everybody has that certificate. But nobody who will ask you that, show me, let your certificate work for me. No. Okay, we have this organic reaction. Complete the following reaction. Complete the following reaction by showing mechanism, or with mechanism, some of the references. So that's the reactions of 40 of alkene, which is propene, and the attached groups, which is methyl, plus what? Bromomethane. So this is bromomethane, and this is alkene, but it contains what? Substituent group. So you have to show mechanism how these two reactants react and form product. You can pause the video, you can try yourself. You have to follow the rules, the 2 rules that I have taught you. You can pause the video for 2 minutes. You can try to do that reactions on the piece of paper. And hence after, once you finish, You click play button, continue to watch, and you will see the corrections, whether you have got it right or wrong. And if you've got it wrong, don't be disappointed. We learn from mistakes, and that's the kind of the students that I want to teach them. I used to teach my students that learn from the mistakes. Don't be afraid to commit mistakes, because the one of the bridge for understanding. What I'm teaching you is almost 75% of the mistakes that I did myself when I was in the advanced level. But I was learning through those mistakes. So solution. So my physical students here are still watching me. Nobody who has taken a piece of paper and tried for himself, for himself. Why? They say, sir, we'll make mistake. Yes, that is good. So CH3, then C, then we have CH3, and hence this is double bond, CH2, and hence you say that this is hydrogen, this is hydrogen, here we have hydrogen, here we have bromine. So, what happens here? Here you have pi bond, sigma bonds and pi bond. And this pi bond is between the carbon atom. So what happens here? So if you, well, here this is a pi bonds, but it is for the same elements. Here you have sigma bonds, but of the different elements. Bromine is more electronegative more than carbon. So you can start. You can say that, okay, fine. So you have CH3, you have carbon, you have methyl, you have that bond with these carbons, this hydrogen, plus what? So here you have carbon, hydrogen, 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 then it's bromine. More electronegative compared to carbon. So bromine will destroy all the bond electrons. So this bromine will become partially negative, and these carbons will become partially positive. Listen careful and look. So then we have what? We have CH3. You can write that CH3, CH2. So I can write that CH3, 2, because they have attached in the same carbon. And as carbons, so then I can have even, can write even CH2. It's well understood. Right? And then you say that plus what? This is methyl, partially positive, plus bromine, partially negative. Because I want to show the bonding, okay? For these new students, for me, I can even continue there. I can show just like this. Then I have CH2, plus what? You have methyl group now, and then you have bromine. But if the pi bond is going to break down, so you have partially part of that organic compounds, partially positive and partially negative. So this is the center. This is the center of this pi bond. Want to make this more nucleophile compared to this, right? So then we say that we pass by a carbon atom which is going to receive what? An incoming electrophile. So simply that we make this one be nucleophile and make this guy to be electrophile. Right? Okay? Fine. So then what we say? So say this is CH3, 2, carbon, single bond, because one bond is broken, CH2. Once the bonds has been broken, it becomes partially positive, partially negative. Right? Right? Or even if that you may not even show this arrow. You can show it there, or you can show it the next step. Right? Either use this, like this, or use the next step. Okay? Okay? So then we have what? We said 3, partially positive, as bromine, partially negative. So that's what we say. That means that this guy is coming here. Right? Yeah? So it's coming there. This says A to C. Right? Partially positive. C. This is 2 hydrogens atom, but we are partially negative. So you're going to have what? CH3. Right? Hence plus what? Now you enjoy the beauty of organic chemistry.